Hey everybody, you able to hear me okay? Okay, great. Let's go ahead and get started then. And we'll start with a few course logistics. So first of all, sadly, this is our last class today. And we'll cover a little bit of AR and VR and then just kind of wrap up HCI. Looking at the calendar though, you've got Quiz 9, Assignment 4, and Reflection 9 are all due on Monday if you haven't done those yet. And then I've posted Exam 3 to Canvas, and Exam 3 and your projects are both due before midnight on the 20th of November. So that's the day we would have our final. We won't have a final. We won't meet virtually or anything. Everything will be due that night. If you're enrolled in the graduate section of the course, the lit review is also due at that time. So let's talk about Exam 3. It's posted on Canvas now. It's 4 questions, short answer, and 1 extra credit question. Same approach as the past 2 exams, open book, open notes, open internet. Just be sure to cite anything that you use. If you take something verbatim, put it in quotes and give attribution. Can't outsource it and can't plagiarize. So that exam will be due on the 20th by midnight, and you'll just submit it through Canvas as a PDF. If you have any questions as you're going through it or anything, just let me know. Send me an email, and I'm happy to respond, or if you want to meet either in person or on WebEx or whatever, let me know and we can set that up too. Even though this is our last class, I'll be around obviously until grades are turned in and everything. So anything that you need, just let me know. Also, I want to mention that the semester final checkpoint is posted on Canvas, and I want to just look at a few elements of it and just kind of discuss those to make sure everybody knows kind of what's expected. So we've already completed the first set of checkpoints here in gray. Those are all of the previous checkpoints, and this is your final checkpoint. And so there are 4 elements to the final checkpoint, and the assignment document describes each of them. Let me just kind of briefly go through them. First of all, due date, November 20th before midnight. Submit everything through Canvas. It'll be a combination of files that you'll need to submit, and I'll talk about each one as we go through them. If for any reason you aren't able to get Canvas to accept a large file, if it's a video or a prototype or something like that, I've put a Dropbox link here, and you can upload files to this link, and I can receive them. Just be sure to name your file in a way that I'll be able to find it. But that should help us with the larger files. If you're a part of a group, everybody is required to submit a brief performance report about the group. It's on the last page of this document. But only one group member has to upload all of the other stuff. You don't all have to upload everything, as long as one person does. So the first part of the project is the usability evaluation, the protocols, the data, and the analysis of that data. So you want to conduct a usability evaluation of your prototype, and you can do that however you want, whatever seems appropriate to you. Most people seem to have pretty good plans on the last checkpoint about what they were going to do for an evaluation. You should aim to use at least 5 people in your evaluation. Some of you I gave feedback to if you had different circumstances where that didn't seem like a reasonable lower bound. then you don't have to do that. But I should say you should try to get as many people as you can. You'll want to collect quantitative and qualitative data, and you can use things like the system usability scale, or create your own survey items. And I recommend using something like Google Forms or something easy like that to gather data from your users. You'll need to write up a brief protocol that just explains what your evaluation was, the steps and everything. And this is important. Please don't conduct any in-person evaluations or anything that would put anybody's health at risk. So we want to do everything virtually. And if you've got a project where it's hardware and you can't do that virtual part of it, I think I've given you feedback already, but you're welcome to just test the hardware parts with people who are in your household. And if you want to test it further by showing other people videos or something, then that's great too. The whole point of the evaluations just to show that you've had people look at your work and give you feedback, and that you've thought about that feedback and either incorporated it or decided not to incorporate it into your final design. So for your submission for the evaluation portion of this, you'll have your protocol, so like what you ask people to do. You'll have the actual data you collected, and then you'll want to have a brief write-up about what you found from that evaluation that you did. It doesn't need to include, it doesn't have to be super extensive. It should be a high-level summary of what you found. You should, when you include the data, that should have all of the data. But for the write-up, I'm looking for something like the takeaways that you got. Yeah, David asked, yeah, it is posted on Canvas already. It's I've got it, the link is on the slide, but I think it's called Semester Project Final Checkpoint as an assignment. So anyways, for the evaluations, mainly with this write-up, looking for what you took away from your evaluation. Okay, so the next part, this is probably the easiest part, and I think a lot of you have already done this for the peer reviews, is this documentation section. And this is should just be a document that just explains what your prototype is, what problem are you solving, how do you launch the prototype and use it. If you need to explain parts of the interface or anything, you can take screenshots and put arrows and explain it. It doesn't have to be lengthy or verbose. It just has to be enough that if somebody picked it up, they could take this document plus your prototype and they would be able to use your prototype. You don't have to tell them like how to use Figma or Adobe XD or whatever. You can just say, open it in XD. You can assume that, we know that much at least. But that's what this documentation is here. So the next portion is a presentation, so a recorded presentation that summarizes your entire project over the semester. So I've got here a table of elements that you need to include in your presentation. I don't have any specific structure that you need to follow or anything. Whatever works best for you, as long as you incorporate these elements. Try to get your total time between 3 and 7 minutes, somewhere in there, for your presentation. And it's definitely possible to be on either end of that and still accomplish all of these things. Just depends on what you're making. If you are a group, you can take up more time, obviously. And I should say that for groups, not everyone in the group needs to present necessarily. Like you don't have to be on video or audio. You can have a few people do that, but everybody needs to contribute to making the presentation. So what you should submit out of this is a video recording of your presentation. So that can just be a screen recording, or if you want to, edit together a video that's some presentation, some close-up of the app being used, whatever you want to do. It can be as easy as making a presentation and having your prototype open and just recording the screen, going through the presentation, showing the app working, your prototype working, and then submitting that recording. That definitely checks all the boxes, but you're free to make it as nice and be as creative as you want with this. Just a reminder, just like with evaluations for the presentation, please don't put anybody's health at risk to make the presentation. So if you're in a group, try to coordinate doing it, if each of you wants to do a section and then edit it together, or if you all want to just join a WebEx meeting or something and record that and then submit that recording as the presentation, that's fine too. Okay, and then this last part of the checkpoint is your prototype, all of your design assets and files and everything that is your final prototype. And so we've talked about each of these elements throughout the semester as to what the prototype needs to do. Everybody who's been turning in prototypes for regular checkpoints is on track, doing a good job of meeting these requirements. And you've got any feedback I had for you about it already. So once you've incorporated kind of your user evaluations and the final work you want to do, then you'll submit all of your prototype files. And again, if you happen to be working in some software that doesn't let you export anything natively, then do the same thing we've been doing, where you submit either a screen recording or screenshots, photos of each part of the interface. Right. And then finally, for groups, so if you're working in a group on the project, each person in the group will need to submit a group performance report. So for that, you will answer these two questions about yourself. So what contributions did you make that you're most proud of? And then anything that you think should be considered when evaluating the overall individual group performance. And then for each person in your team, for each one of them, list their contributions, and then classify them as below average, average, or above average within the group in terms of their performance. And that just helps me to make sure that everybody's contributing to the group and has made an effort. And that is everything about the semester final checkpoint. Are there any other questions about it? Okay, so feel free to send me an email or message or whatever if you run into questions as you're finishing all of this up, and I will get back to you on it. All right. Oh, one more note before we get into today's topic. The class climate course evaluations are posted in Canvas. They're on this little class climate tab over here. So far, only 6 people have submitted for our class. So if you would please take some time to go fill this out. It really helps me in terms of improving the course for future semesters, and just getting feedback about what was good, what wasn't good. It's very helpful to me. Okay, here's a question. So we don't have any class meetings after today and finish everything by the 20th. Yep, that's correct. Yeah. This is our last lecture. Okay, so be sure to do this within the next 4 days, this class climate survey. Okay, so last time we spent some time looking at making things, electronics, 3D printing, looking at what we can learn from toys and other products, and then talking about just a variety of robots that we have in the lab that I work in here. So today we're going to talk a little bit about augmented reality, virtual reality, and then we'll kind of sum up HCI and kind of what we've looked at this semester, and pose a few questions that are a little bit critical of HCI just to think about as we wrap up. Okay, so let's start with augmented reality and virtual reality. All right, so let's kind of just a fun video that's from an ABC show, Modern Family. But just to get us started thinking about virtual reality and augmented reality. So in the clip there, he's playing a virtual reality game, and it kind of brings us into the place where we are with this, where it's becoming popular enough that we see it featured in TV shows. But also, it's kind of still a bizarre thing to see somebody running around with all this equipment on, completely immersed in their own world, playing the game, kind of unaware of what's going on around them. And of course, it's an exaggeration because it's on TV, but it does bring up a lot of kind of HCI issues when we start to look at designing for this kind of technology. So I want to start by pointing out this kind of spectrum that contains, on one end, what we would consider, I guess, a pure virtual environment or virtual reality, and on the other end, what we would consider a real environment. And in between, everything in here, we can classify it as mixed reality. So with augmented reality falling in here, and what we call virtual reality falling in here as well. So there are quite a few terms associated with different levels of virtual reality or augmented reality. For our purposes, we're going to talk about them somewhat mixed together, and we'll focus on the two endpoints of virtual reality and augmented reality. But just know that this is a spectrum, and there are different ways to look at this, but this is a pretty common one. So I do want to mention, as we get started on this, I was looking kind of to see what recent resources were out there just for AR and VR, and I found actually a pretty nice and recent, within the past year, free course, and all of the videos are on YouTube, so I've just linked the playlist here. They have a foundations of augmented reality and then advanced augmented reality, which goes through a lot of the theoretical constructs, and then also kind of just the practical, building things for augmented reality, and doing tutorials on that. So it's quite a bit of content, and it's pretty good. I've only watched a few of them. But I think it's a great resource if you're really interested in this stuff and are looking for a starting point. This was really nice. Also, I should mention this book. So this is Creating Augmented and Virtual Realities. And so I have used a little bit of content from it, and I read through it over the past couple of days, and it's a pretty good resource. It's kind of got some nice history of kind of the field of AR and VR and where it is today. It's from 2019, but it's fairly up to date. And it's got a nice overview of kind of everything and kind of what you need to think about if you're designing in this spatial computing area, as you can sometimes call it. So I thought I'd mention those two up front. If you're interested, those are definitely great resources. So starting with virtual reality, where did we begin? So virtual reality, the idea that, and most of us are familiar, is a simulated experience, right? The idea of transporting you to a different space and kind of transporting your senses somewhere else. So we tend to use our sense of our vision quite a bit. It's pretty powerful. So virtual reality up front focuses on moving that sense into a virtual world. So that's why we see that most virtual reality applications are focused on visual displays, so glasses or headsets that you wear. Although that's not always, that's not a requirement for virtual reality. So you can also think of cave environments, so environments where like everything is a projection surface, it's fully projection mapped, and you can feel that you're immersed in a different world, even though you're not wearing a headset or anything. And so that has some advantages and some trade-offs. But certainly the most common thing that we think of when we think of virtual reality is we think of wearing the headset and kind of moving our head around mostly as a sense of navigation. And then more recently, we've seen a lot of commercialization of these headsets. We also think of having some kind of controller in your hands, right? Typically 2 controllers. You're using some kind of input with your hands, and it may be a movement through space, like a gesture, but also it's usually a tactile with your fingers kind of movement. And usually those controllers are giving us some tactile feedback, some haptic feedback, some vibrations or force feedback. And while that's the most common way of doing this, it's certainly not the only way. And there are other systems out there, but that's the most prevalent in terms of commercial systems and systems that people are building for right now. So I mentioned here that also really big aspects of virtual reality. Audio is probably the second biggest area that comes to mind when you think about designing these experiences for a user. Typically the headsets will have at least stereo audio so that you can do some type of spatial feel with the audio design. And that's really useful for when somebody's immersed in a virtual world, being able to have a sound, have a physical location in that virtual world that corresponds, and then be able to look over to that sound. So in general, as we design these systems, we'll find that the more we can couple senses tightly and make that feedback loop work for us, the better and better the virtual reality experience will be. Where we start to have problems is where either the modalities conflict with each other or we do a poor job with one of the modalities. Okay, so there's a comment, the treadmill. Yeah, we'll actually look at that. Yeah, like the omnidirectional treadmills that you can use. So that's another part of virtual reality, locomotion, which seems really cool. I would really like to try one. I've not tried an omnidirectional treadmill yet, but I would like to. So I should tell you a little bit about the history of VR. Surprisingly, if you remember good old Ivan Sutherland from 1968, is kind of credited with as being one of the first people to build a VR system. So it's got roots way back, but it's really only recently that we've seen consumer level commercial success, and probably the Oculus Rift was the big one that appeared. in 2010 as a prototype and was released on the market, I think just a couple of years later. But since then we've seen more and more VR platforms develop, and we've also seen some platforms that leverage things, like your phone. And so we've seen things where you actually take the phone and put it into a headset, and then you use the computation and the screen of the mobile device, focused through some lenses, to actually do all of the VR experience. And so that's something that most people have a smartphone, and lets them kind of experience some of this without needing dedicated hardware. So the basics. So this is an Oculus VR headset. So typically you'll have a headset like this. You have stereoscopic displays, so one screen for each eye, and so that's to give the feeling of depth, right? You'll have the ability to do binaural audio and haptic feedback as well. So here's a few figures. I was talking earlier about that projected environment, the cave environment, so this is kind of a render of what that looks like. You'll see these in different places. Universities typically have them for different types of research. Museums will have them sometimes for different exhibits. And sometimes you'll see things like theme parks, amusement parks will incorporate kind of some of this virtual reality into their attractions. So Disney is a standout example. Disney Imagineering. If you look at a lot of work that they do, they incorporate a lot of projection mapping into their worlds that they create. It's not pure virtual reality, but it certainly plays in this area of these concepts. Here are a few consumer devices. So here we see some of these tracking stations. So the different consumer devices will use some of these kind of either beacons or lighthouse devices to help localize where the user is who's wearing the headset, so that they can track their movements more precisely. Because if you think about, if you just have a device, like you just have the phone, right? The only thing that you have to track the user's movement is the IMU, the accelerometer, and the gyroscope inside of the phone. And then in a lot of augmented reality cases, you'll use the camera system of the phone, and you'll combine those two to get a good idea of the space that the user's in and where the device is located in that space. But for these higher fidelity systems, you typically have an external tracking system that will use some kind of IR markers or something to locate the person or the user and their head pose as well in the space. So I'll show you a video of this is Oculus, so this is Facebook. One of their kind of visions for virtual reality for a workplace. So let me play that. Okay, so that's kind of interesting. Kind of looking at that experience that they're presenting there, you really can gain a lot looking at the different interaction elements that they're kind of showing. So the first thing that's noticeable is that I should say this is a fairly recent video. I just pulled it a little bit before lecture, so I haven't had time to look into all of kind of what they're implying with it. But if you break it down, you can see one interesting thing is that this is not so much this headset that she's using kind of to complete office task or general computing task, it looks like. It's not necessarily pure VR because there's kind of this awareness, there's this pass-through where they're using the cameras to see what's going on in the environment around the user. Now, that kind of gets into almost an augmented reality situation where you're bringing in elements of the actual environment. And so it's kind of interesting, especially interesting when she gets the keyboard to use, right? So that's one I'll have to look into more, because I can imagine if you were used to typing without looking at the keyboard, it's one experience, and if you need to look at the keyboard every now and then, it's probably a little bit of a different experience when you have the VR headset with its interfaces and the physical keyboard down below. But one thing that you do see a good example of in this video for the product is the way that things are being manipulated. So a lot of VR headsets and AR headsets will use hand gestures to manipulate things. So in this case, there are no controllers or anything being held. The headset itself is identifying hand gestures and pinching and pointing kind of gestures to interact with different elements that are being shown by the visual interface. It also kind of captures the audio feedback. That's a big part of designing these systems to make them feel very responsive to the user. It's just kind of these slight audio cues when you're clicking on something. So it's definitely an interesting idea. I've never personally used a VR system or an AR system for the purpose of looking at an interface of kind of what I would usually imagine being on a 2D screen, right? But you could see how that could have a lot of benefits, where you've kind of got, this ability to use all of the physical space around you and to, put your virtual work into your physical workspace. So it's certainly an interesting area of design. And you see a lot just in that one promo of kind of all the little things that you have to think about for this. And of course, what's interesting also is that the video seems to show off that the device is quite portable, right? It's not tethered to anything. It's, she moves from room to room with the VR headset. And I should highlight that this is kind of a challenge when it comes to designing VR and AR for these systems that are not tethered to a bigger computation device that has more power, that isn't trying to optimize battery life. There are a lot of challenges associated, especially with game development, right? Where you need to limit your use of resources so that the user can have a good experience on the platform. Obviously, that's something that we get better and better at as time goes on. And there are a lot of tools to help you do that. But it is an interesting point. So just to briefly touch on some of the applications of VR. So, anything, we can do telepresence through VR. We've talked a little bit about doing therapeutic tasks through VR. So allowing someone to go into a scenario to experience something that maybe is something that causes them anxiety, to help them adapt to that through exposure therapy. And we've talked about training opportunities, specifically anything that's dangerous, like military. We'll use VR systems to help people train for scenarios that they need to be familiar with, but making them familiar with the real scenario would be risky. So some of the current research, some of the problems and kind of just areas of development and focus within VR, and I should say this applies to AR as well. Health issues, so especially with younger children, there have been some studies looking at the effects of like a lot of prolonged VR usage by younger children, and there have been some findings showing that there may be some disadvantages to having younger children use VR systems on a regular basis or for prolonged periods of time. It's definitely an ongoing area of research, so it's one of those things where we'll learn more as we go. But it's something to keep in mind, that kind of the health effects on anyone of using VR regularly is not well established yet, just because it hasn't been such a pervasive thing. Safety is a big one. These worlds are very immersive. You really do start to lose your awareness of what's around you, especially when the interface or the game or whatever is encouraging you to physically engage with it, and whether that's to move around in an area or just to use your hands and kind of lean around. You'll see people definitely lack awareness of their physical surroundings if they're fully in VR, and a lot of the VR systems will indicate in the system where the boundaries are to try to help users not get into a safety issue. VR sickness is a big deal. So making these systems in a way that doesn't cause people to become ill from kind of the disconnect from the simulated movement and the actual feelings that you're having. This can vary by person, but it can also vary by system and by the performance of the system. Where you can really, you can make people feel pretty bad if you don't have a system that performs well in terms of accurately simulating the visual experience. And also this extends into how you design things, right? So when you design different elements in a virtual world, you really have to think about if you're going to animate something, right, make sure you animate it in a way that scales reasonably, based on how a human, what our world is like in the real world, right? Because you have the capability to do things that don't occur in the real world, but they can really cause problems. And so if you think back to like a lot of the sensation and perception stuff that we looked at early on in the course, a lot of that is really important in this kind of design. Also, it's a comment, VR sickness kind of stops after using VR for a while. Yeah, I think that's definitely a lot of people's experience, is that you kind of adapt to the system over time. And that's definitely an area that, when they design these systems, that people look at is, how is it affecting people in terms of if it is causing them any sickness. And sometimes some people are just extra sensitive to certain things. So it's a really interesting area. Thankfully, we do get better at this as the technology gets better, but we also have to think about it when designing. So also just things like if you're going to like pop up a text interface or something in the virtual world, you need to think about kind of what physical size it should be and how it should be distanced, right? Because for a lot of these systems, depending on the sensors they're using, a user may have to actually look down to see things that are very close, and that can actually be pretty exhausting. It can cause some fatigue after a while of having to do that. So these are all things to think about. So let's talk a little bit about navigation in VR. So I'll play this clip.
Navigating mobile VR environments is a challenge due to limited input options and a requirement for hands-free input. We explore the use of head tilt to enable hands-free omnidirectional navigation. We evaluate head tilt by itself and as a modification of walking in place. While walking in place input was found to be most immersive, our user study found head tilt navigation to be faster than joystick and walking in place input.
Okay, so that's kind of interesting. That's a video from I think it was a Chi conference several years back, but it kind of I don't know. I haven't used that system myself. It doesn't look too pleasant to me, but it brings up this issue of people are in a virtual world and they may want to navigate through it across a great distance, but how do you map that to their physical movements in their physical world? And so we see different techniques for that. In that case, they were using the head leaning to indicate kind of where they wanted to go and just staying in place and kind of pretending to walk. Let's see if I have another. So here's the omnidirectional treadmill. Well, this is one omnidirectional treadmill. And so you can see how this can support quite an interesting set of interactions, right? So there you've got the VR headset on now, and the hand controllers. So that's the Vive headset. So that's just one example. There are a bunch of different omnidirectional treadmill kind of solutions out there. That one's kind of a nice one. It's probably pretty expensive, pretty big setup, looks like. Got the person's safety tethered in. Now, in a lot of cases, if you're doing training, like military training or something, you're going to have that system because you do want people to really fully engage physically, and you have the resources to set up a dedicated facility to accommodate them using that system. Now there are even some very low-tech omnidirectional kind of treadmills, like just rollers basically on a platform that you can walk on. I've seen some of them that use special shoes mixed with a certain surface that kind of let you just move in any direction in place without actually moving. So that's definitely I would say that's kind of the highest fidelity simulation you're going to get in terms of navigating in a virtual world is using something like an omnidirectional treadmill, but that's not always possible, and it's still kind of an uncommon thing. So we do have some other techniques that are commonly employed for navigating within VR. So linear movement is a pretty common one, and we see this done typically. So this is the person's hand controller in the virtual environment, and it's showing a trajectory of where the user is going to be. They're going to be pulled along this curve through the environment, and so a lot of consideration goes into the animation here that you're going to do as you move them from place to place. But this is one way to do this without needing any extra equipment or anything. They're just using the hand controllers that they have, and it's going to just move the world around them. You can take a more of a teleportation approach, where you're kind of just doing more of a hard transition. Maybe you're lifting someone up out of an environment and setting them back down somewhere else in the environment. There are a lot of variations you can do on this, and certainly if you're doing games or other creative applications, you can work this into the theme and the story and the elements of the experience that you're creating. So the third one that I want to mention is particularly important for augmented reality, is a scaled movement. And this is sometimes called ant mode. And so the idea here is that when you're in augmented reality, you have this kind of hard problem that the user is seeing the real physical world with virtual objects placed in it. But if you were to move them kind of through that space without them actually traveling through it, it can become really disorienting. So one technique is to kind of scale everything big or small and use relative scale to help you make those transitions without being kind of too jarring, which is kind of interesting. But as we talk about AR, we'll see how AR is nice because it can allow a user to kind of move around more in their physical environment. So, augmented reality. There's a wide range of platforms for augmented reality. And it probably doesn't surprise you that the most popular platform for augmented reality is just a phone. And so what we see here is using the phone's cameras to show the user a video feed of what's in their environment, and then using the cameras plus some of the sensors in the phone to map that environment and to place objects, virtual objects, in that environment on the screen that they're looking through. And so that's probably, that's the most popular device that's used for augmented reality. To an extent, we can say things like photo filters and a lot of the things that we see on social apps, like things you see on Snapchat. They are augmented reality in that they use some of that same tracking techniques, typically to find a face and to virtually augment it within the app. Less popular but more powerful devices that we see are things like Microsoft HoloLens. So this is just a headset that you wear that you can see the environment around you through it, but it has the ability to project onto what you're looking through to add objects to your environment. And it's got a lot of sensors in it so that it can map out the environment and anchor things kind of where they belong in the environment for you. So let me play this video. This is kind of just the setup process for a HoloLens.
Hello. Let's explore useful tips to get stuff done on your HoloLens. Select a hologram or button within arm's reach by tapping it with your finger. This is how you interact with holograms nearby. Select a hologram that's out of reach by targeting it with the ray from the palm of your hand. Then tap and release your index finger and thumb to select it. This is called air tap. Let's learn how to move holograms. Grab and hold the flower using your thumb and index fingers and move it into the circle. Release your fingers to place it. Great. Now try it a couple more times. Nice work. One more time. Perfect. Let's learn how to resize holograms. Move your hand closer to the flower. Once the box appears, grab and hold one of the corner handles to make the flower smaller, grab and hold one of the corner handles, then drag it closer to the flower until the flower closes. Good job. Let's learn how to rotate a hologram. Move your hand closer to the flower. Once the box appears, grab and hold one of the handles on the sides of the box. Then drag it sideways until the flower faces you and opens. Next, we will show you how to open and close the Start menu. Here's how to tap the hologram again to open the Start menu. Do the gesture again to close the Start. Let's learn how to exit an immersive app like the one you are in right now. See the button at the bottom of the Start menu? This is the button for exiting an immersive app. You've learned all the tips in this collection.
So that kind of gives you an idea of kind of the guided process with the Microsoft HoloLens, kind of teaching the user the common ways of interacting with different elements of that system. So I've had the chance to use the HoloLens a little bit, not on a regular basis, but it's very impressive, and it's really it's quite good at doing what it does. So it's interesting to see it as it evolves. All right. So just to talk a little bit about kind of one of the most important parts of the whole augmented reality process, and that's the underlying technology that allows us to put virtual objects into the physical world and maintain that mapping. So kind of one of the most successful techniques that's used today is called SLAM, which stands for Simultaneous Localization and Mapping. This is something that's well known in robotics, because robots need to navigate through environments. So they need to build maps of an environment and know where they are in the environment. And in a similar way, an AR device needs to accurately build up a model, of the room or the world that it's in, and it needs to know where it is in that model. And so, with something like the HoloLens dedicated, device, it's using a number of cameras and accelerometers and gyroscopes to sense kind of its own movements in space, but also to look for landmarks and build up a representation, a 3D representation of the environment that it's in as the user moves through it. Now, what's more impressive is that we are able to use something like, this is just an iPhone with a single camera, to do pretty decent augmented reality. And so that's a little bit puzzling maybe as to how that works, because typically to build up a 3D representation, you either need two simultaneous viewpoints that the distance they are apart from each other, or you need something that allows you to actually measure distance. But kind of the clever trick here, which is shown in this diagram, is a combination of using the phone's inertial measurement unit, so the gyroscope and accelerometer that's in the phone that measures its acceleration and position in space, to use that data in combination with camera data, so images taken over a series of over time, right? And combine that to create a 3D representation of the world. So what you do is you can actually use that IMU data to kind of what we call dead reckon how much this device has moved, right? So like if I just turn it a little bit, it has some guess as to how much I turned it, and it's got some error in that guess. So every time I do that, that error adds up. So I can't just spin it and expect it to know exactly what's happened to it. There will be some error if I'm just using the IMU alone. But if I combine that IMU with images of the environment, and I process those images, and I start to look for planes in the environment, we can create a pretty good representation of the world, even with just a single camera and an IMU. And so here's showing you a little bit of kind of visualizing that representation that exists in the system. So here you can see the scene itself. Here you can see these various points that are being tracked. So it's a point cloud. So these are points in 3D space. Here's kind of a transformation of that, looking at those points in space. And here's a depth map of that. So you can see this outline here is roughly this outline here. And so that's, you know, a visualization of what the system is computing constantly. So we really saw quite a breakthrough in terms of doing this with a single camera on a phone. In Apple's implementation, they call ARKit. I believe Google has AR Core. They may have changed the name by now. Pretty much every major tech company has some internal SDK available to handle all of these details for you, so that you don't have to worry about it as a developer, as an interface builder, and an interaction designer. You're not worried about solving this problem of building a 3D world and knowing where the user is in it. You're just going to be given that data from the operating system. But the way that at least Apple has had good success with this is fusing that IMU data with the camera data, like we've talked about. And so what we typically see, at least in the early versions and with older hardware, you get about 30 frames per second of video data. But for the IMU data, you're getting about 1,000 frames per second. So much higher spatial or temporal resolution there. And so that kind of helps supplement these relatively low frequency visual images that you're getting. And so it's really a balancing act that's made this a good experience. So here are two videos. On the left, this is using an app that Apple has. It's called Reality Composer. And what it does is it lets you do just some basic, AR design directly on an iOS device. So you can see on the left, this is the design process of making something in the virtual world. And I should say that my wife was kind enough to screen record herself doing this and send it to me. And so here you can see on the right, placing that object, and you see it staying in place as you walk around, more or less here in the world. And so that's leveraging Apple's kind of just native AR kit, and this app lets you do that. So it's pretty fun to play with, and it can kind of get you a feel for designing things in the AR world. So let's talk about just kind of a few important aspects of designing for AR and VR. So first of all, we've mentioned this a million times. You always want to leverage multiple sensory modalities if you can. So audio is a big one, and haptic is a big one, in addition to the visual modality that you use. One of the most important things, at least right now, when designing for VR or AR, is that you want to design for a variety of failures or unpredicted scenarios. Unless you are specifically just using a platform that's going to be in a controlled environment, if you're doing something like for a mobile device, or for even like a HoloLens or something that's going to be free to roam through a bunch of an environment, you can expect that at some point the lower level systems may not be confident about where the device is in the world or what the world looks like. And so as a designer, you kind of need to handle those situations in a graceful way. And that depends on what your application is as to how you handle that. But you don't want to do anything too abrupt. So we see, all of the design principles that we've learned for interaction design apply here, but we've got this added 3D dimension, right? We've got a whole nother spatial dimension that we're working with. If we're working in augmented reality, we've got these real-world objects that are constrained that we don't know about necessarily when we're designing the experience, right? We're not in everyone's home or wherever they're using this. So you may not be able to necessarily expect everything. So you've kind of got to think about that ahead of time, and of course test and prototype a lot. We've talked about so designing for those failures and problems, also for optimizing your resource usage on these mobile devices at least. And then one big interesting area that's been a technical challenge for a while is if you think about multiple people, imagine two people in the same room, and maybe they've just got a table in front of them, and they're both going to open up an app, an AR app on their phone, and point it at the same physical location. And they're both going to have virtual elements that they control and view in this augmented reality interface. But you want them to be synchronized. We should have a shared awareness now of these two devices and that they're in the same space. This turns out to not be an easy problem to solve necessarily. There are some tricks you can use to solve it, but you can imagine kind of the difficulty of matching up. It's a visual search problem, right, of matching the environments. And to do that on a resource-constrained device, it can be a problem. And the other thing that factors into this is that if you were to, say, have users using two different platforms and you wanted them to share the same virtual environment, same augmented physical environment, augmented with virtual elements, this problem becomes a lot more difficult because currently there are not a lot of open standards or support for open transmission of the data that these systems collect. So, the ideal thing would be for the two devices to be able to communicate with each other about what they each see in the world, and to combine those maps to get a better resolution here. But that's not easily done when the platforms are different, and it can be difficult even on a single platform. So that's still an interesting area with plenty of problems to solve. Kind of a similar problem to this problem is placing a user in a large map. If you think about a map that's like several city blocks or something, that's actually a somewhat difficult problem still. You can rely on things like GPS sensors to help that out, but apart from that, still a lot of difficulties. I've included some of these in this table, these 8 key barriers. This is a Kai 2020 paper about AR and VR design, and they followed a number of different people working in AR and VR at different levels, and kind of looked at their challenges as they went through the development experience. So I've highlighted kind of what I thought jumped out as the most important, just a lack of really, knowing what's the best thing or good design in AR or VR. It's still newish. And then kind of the difficulty of incorporating all these modalities together is quite a challenge too. So I want to briefly think about some of the security and privacy issues that occur with augmented reality. So some things that you can think about here is you can consider, first of all, that the sensors are always on by the nature of experience that you're designing for. You have to have these cameras on, these sensors on, which is not necessarily a problem in itself. But if you start to think about more than one app using this, or thinking about an AR operating system, you can start to think of how is the user going to have a mental model of what's shared with which app. Because at a low level, you've got camera data and pixels and depth measurements, but at a high level, you could just be telling an app, oh, you're in a room, you're on a flat surface, and those have different consequences and implications. Similarly, how do you deal with malicious activities in AR? So, someone overlaying malicious information, causing sensory overload. Right now, we don't think that's too serious of a threat because it's pretty easy to remove these systems from us. But if you think about it being more difficult to exit the interface, that could be an issue. And of course, just basic privacy and security concerns. There are some upsides. So kind of having a private display that no one else can see is a huge upside of AR. So I'd like to
I don't want to overhype this,
play this for you. So I think that's kind of a great clip to summarize usability and user experience. That's from Parks and Rec NBC show, and showing you've got this highly functional thing that's built, but the users really get their joy out of the animated character. And so I think in summary, if we had to sum up everything we've talked about this semester, I would kind of break it down just to these points. First of all, we're always concerned about understanding the user and what their needs are, in that we care about humans in general, their characteristics, how they perceive the world. We care about the specific domains that we're working in. And then we take that and prototype iteratively, and we get feedback from those users until we arrive at something that works. And throughout that process, the two goals are usability and user experience, and that's HCI in a slide. If we were to think a little bit about HCI and maybe some of the things that maybe we could be critical about, HCI is definitely a mix of different fields. So we might ask, does HCI actually distinguish itself apart from just combining other fields? What is its contribution on its own? You might think about some things like taking a more design-centric, critical approach. So we tend to base everything on empirical approaches and kind of more of a scientific method to develop our design principles, but there's also some merit in kind of what's more of an arts approach, where you give criticism and subjective feedback and use that to contribute to interaction design and HCI. And then, of course, kind of the major question that we're always left with is, what should HCI focus on? What shouldn't it do? Are there limits? Are there things that we shouldn't design for? Can we harm people by designing a certain way? Does that matter? Thoughts like that. And these are definitely things that are an ongoing discussion in the HCI research community and in industry as well. So I think that's kind of a good place to leave our semester. I want to just give you list of action items. Here are the due dates. We've got this set of items due on Monday, homework, reflection, and quiz. And then your final project and exam are both due on the 20th. This is our last lecture. I want to thank all of you for being here this semester. You've all done great work on your projects. I know it's been strange for you and me to not meet in person, but I do thank you for working with me, and I hope that us not meeting in person has had some positive impact on the world. So I'll wrap up there. If you have questions about anything over the next week or so, just let me know, and I'll be here to answer those questions. Otherwise, please fill out the course evaluation, and I have really enjoyed our classes this semester, and I hope you guys all have a good end of the semester. Things don't get too stressful, and then I hope you have a good break. With that, I will say goodbye. Thanks everybody for being here, and it's been a great semester.